All right, class. So, okay, Khalid is having network issues. Memuna, am I audible to you? Memuna, am I audible? Hello? Yes, class, am I audible? See, I'm starting with electric field and charges. So, electric charge is the basic property that comes when we are discussing it. It is the intrinsic property of matter that gives rise to electric forces. So, in this topic, what all things you have to remember? Electric charges definition usually does not come. SI unit you have to remember at any cost. Main thing you have to remember is CGS unit. If the paper is difficult, you can be asked to write about the CGS unit. Two types of charges exist that you all know. See, from here, the most important thing is remembering the value of electronic charge. So earlier when you started with class 12, at that time you were having difficulty in remembering this value. But now after the whole completion of syllabus, you are aware of how much usage this electronic charge has. So you have to remember this for proton and electron. From here, this part was important. This is... Yes, when it comes to charging, that is transferring of electron. Class charging term also can be mentioned to you in the exam. Charging term can also be there in the examination. So if charging term is given, don't get confused. That refers to the transfer or redistribution of electron only. How electron is gained, lost, that we discussed. So negatively charged body is there. It will gain electron. Transfer of electron only occurs. Proton do not get transferred. Protons do not get transferred. It's the transfer of electrons that occurred. So negatively charged body has excess of electrons, and all the electrons will be having its own individual mass, 9.1 into 10 to the power minus 31 kgs. So that will result in greater mass also. Greater mass. Whereas if we talk about positively charged bodies, it loses electrons. That deficiency of electrons makes it positive. The way in semiconductors we saw electrons leaving make holes creation, same thing. And since masses also of individual electrons are going away, so masses decrease. From here, conceptual questions will only come. Methods of charging can be asked to you: charging by friction, conduction, induction. From charging by friction, more than the definition, you can be asked to this part: positive and negative, which has the positive charge, which has gained the negative charge. So these are by convention mentioned in your textbook. So these two you have to remember: glass rod positive, silk negative, and second one wool positive and plastic negative. This you have to remember by sign convention. This will come. Then these types of questions, as you have discussed in the class, if one is positive, one is negative, means here in charging by friction, no, in this first topic, you just have to remember which is weakly bounded and which is strongly bounded. So which two electrons are, whichever electrons are strongly bonded, that will be mentioned to you. So it will be having difficulty in losing the electrons because bond will not break. So if the electrons have high, tight, strong bond, it will be more of positive because electrons will not be moving. If it is electrons are easier to remove, that body will be deficit in electron. So this loosely bound and strongly bound concept you have to remember in charging by friction. In charging by conductions class, most probably you will be getting, if a question comes on charging by conduction, it will be mentioned to you that in charging by conduction you have two objects which are identical. When as soon as you see the term identical, or it will be mentioned to you like radii are same for spheres, or for cubes the sides are same, for squares the sides are same, like this it will be mentioned. So if such is the case, then whenever they are brought in contact, add up the charges divided by 2, means take out the average for the transfer of electrons, because it gets divided equally. So you also have to see how to divide two things equally. Take the total thing, divide it by 2. So take the total charge, divide it by 2. These questions come a lot from conduction that we discussed in the class itself. In charging by induction, you will just simply have questions like this. If like this, make this isolated sphere positively charged. So what will you do? Whatever according to the question, you will bring negatively charged. What will happen? All the positive will stick on one side, negative on opposite side. Then if you want the body to be positive, then earth it. As soon as you perform earthing, then what will happen? When you perform earthing, the potential becomes 0. All the negative charge get neutralized. It moves into earth. So now you are free to remove the rod, because now negative charges are not present to neutralize your positive charges. Fine. So this is the introductory part from which the questions can come. Then you have your Coulomb's law. In Coulomb's law class, Coulomb's law, basically the questions from Coulomb law can be directly asked like this also, according what is meant by Coulomb's law. So you will say this part you have to mention from here to here, that according to Coulomb's law, electric force between 2 point charges is directly proportional to product of magnitude and inversely proportional to the distance square of distance between them. F is equal to K Q1 Q2 by R square. You have to remember, where K is 1 over 4 pi epsilon naught and K's value is 9 into 10 to the power 9. Then from here, epsilon naught can be asked. Epsilon naught's value mainly you have to remember. Epsilon naught specifically questions are not asked usually in the exam. Epsilon naught. But remember, it is absolute permittivity of situation. It basically governs the forces with respect to medium. You have seen this epsilon naught was for air, this value existed 8.85 into 10 to the power minus 12. When you change the medium, it was totally different. All right, class. Properties are very basic. Properties you can see. So from Coulomb's law, we'll practice directly questions. What is there to remember is this term, class. This becomes very confusing, especially students who are doing their investigatory projects on Coulomb's law. They remember, if you are asked, the external examiner can ask you the ratio between epsilon and epsilon naught, which is equal to K. What will be confusing is whether it was epsilon naught on the numerator or epsilon on the numerator. So be clear that this is epsilon divided by epsilon naught. This is epsilon divided by epsilon naught. But when it comes to force, it will be force F naught by F in medium. Please remember this part, because it will become very confusing when you write it. Clear? These types of questions we'll practice it right now only. Question practicing, I'm just revising the theory first, then we'll move on to numericals. Class, I hope this you will remember. Khalid's internet is still not working, no? Memuna, are you listening or not? No response from Memuna, only Salman is answering. If Memuna is present, let me know, Memuna. Memuna, where were you? I was calling your name. I hope I'm audible to you. You are attending the class fully? Okay, network issues. Then in Coulomb's law, the basic point that you have, that is important, that I have told you. So from the first topic, I have told, from Coulomb's law we discussed, now coming to electric field. See, class, in electric field was what? This was a space around a charge where you could experience the forces, all the forces that, not all the forces, basically electric forces. So electric field was that space around that charge. So if you bring another charge, which you call it as a test charge, you will be able to feel this force exactly in that sphere, wherever electric field exists. Now, electric field topic, this part, derivation is not there. So electric field's definition, when you write it, no, do mention this point by yourself only. whenever you're writing that electric field is forced by unit charge, so limit Q tends to 0, F by Q, E is F by Q, and E is equal to F for Q is equal to 1 coulomb. That is, electric field is equal to electrostatic force for 1 coulomb of charge. Mention this point. If possible, if some things you are missing on, you can keep on writing it somewhere, what all important things are there for your final revision whenever you do it. All right. So SI unit, this is the, so when electric field definition comes, no, this part SI unit, scalar or vector obviously, this part you directly mention. Otherwise, no questions are from this part specifically. Then questions are there from point charge. This derivation also can come. This is a very small derivation. So in 2 markers, you get this electric fields for point charge. You get electric fields for point charge in this. Fine. So electric field, if you have for point charge, do write this using Coulomb's force. And then class, direction of charge is very important. All the vector quantities that have specific charge or having specific direction is very important. You please remember, for positive charges, you run away from the charge. For negative charges, you move towards the charge. This you have to remember for electric field, because without that, you will not be able to solve questions. So till now, if you have forgotten what was the direction, just try to remember it from here only. Direction, then direction combined with this formula, questions come from this. Again, K is equal to epsilon by epsilon naught. That will become confusing. Please remember, it is epsilon by epsilon naught, not epsilon naught by epsilon. Epsilon will come first, then in the denominator you have epsilon naught for both forces and electric field. Then questions we practiced. C class, superposition principle we have till now studied in wave optics also. Superposition principle, there is nothing to discuss in this. Whatever individual electric fields are present, whatever individual forces are present, if many charges are present, more than 2 charge, n number of charges are present, 3, 4, 5, 6, 7, any type of charge. Even if 2 charges are present, for 2 charges you can calculate, for more than 2 charges. Not only for electric field, for electric forces also. You have to vectorically add it. Proper parallelogram law you have to apply, triangle law you have to apply, polygon law you have to apply, whatever law is applicable. Mainly we use parallelogram law, or the Cartesian form also you can apply. If you don't want to use the polar form, you can use the Cartesian form, I cap, j cap, k cap. In terms of that also you can solve your answer. Because in your question, nothing will be specified. We use Cartesian form or polar form. So you can use whatever way you are convenient. Mainly, the questions get solved using parallelogram law. Angles are given 120 degree, 60 degree. Usually a triangle is there like this. So superposition principle is directly based on this. Then you have dipole moment. See, dipole moment is also a very important topic. Whenever you are revising electrostatics, the most important one of the most important topics is your dipole moment. So from here, monopole moment, this does not come in the examination. You have to remember directly dipole and dipole moment. Direct question on dipole can also be asked to you. What is the definition? What is meant by a dipole? Write the formula for its dipole moment. This can be asked to you. So dipole formula is different. So dipole meaning you have to write two equal amount, means having same magnitude, opposite direction or opposite signs. Equal and opposite magnitude. Remember this. System having equal amount of positive and negative charges at a small separation. This definition is also valid, but for you, you should remember plus Q minus Q with a certain separation. And take the magnitude. See, magnitude is same, so you can take any of the charge. So pick any of the charges and multiplied by the separation. Now in dipole moment, what can be confusing for all of you? You will forget the direction. In electric field, you will remember that positive you have to run away and negative towards. But when you talk about dipole moment, you forget the direction. This is negative to positive. From the negative to positive. Always remember, because this is dipole moment is a part of your chemistry also. In chemistry, direction is opposite, and sometimes students write that direction in physics. In physics, direction of electric dipole moment will remain minus to plus, negative to positive. Do not forget this. Certain things are there that become confusing at the end. So do specify whenever you are remembering. That's why we are revising all these things so that it does not become confusing for any one of you. Fine. So electric dipole moment, in that you have to remember it. Rest of the questions for electric dipole moment are fine. Then these derivations come. Axial and equatorial, they do come in your exam. So axial and equatorial derivation, do it thoroughly. Any can come. Derive the expression for electric field on a point that is located perpendicular to it. So equatorial you have to write, or it will directly mention axial field, axial electric field. So you know the formula 2 kpr by r square minus a square to the power whole square is there. But mainly this formula is also used. But if you have the radius of the separation of greater than the separation between the dipole, then you directly write it as 2 kp by r cube. Today I'll share you a formula sheet also, short formula sheet also. I'll compile it, not today. I'll do one thing, I'll compile all the formulas together. So at the end, I think it will be helpful. Or yes, Khalid, you're in, this voice is working now. Audio is connected, Khalid? Or still having issues?
Yes, teacher. Now it's working.
Now it's working. Okay, Khalid. So class, let me know if you all require that formula sheet. I'll be compiling all the formulas and I'll then make it into a PDF and share on WhatsApp.
Yes, ma'am, it would be useful.
It will be useful. I'll do that. Give me some time, not today. After a few revision classes, I'll share that also, because this will also take time for me. Okay, so
Yeah.
Ideal dipole approximation part will be used maximum by you. Now see, in your subjective questions, because you are giving your board examination. So this formula can also be used. Many a time students do not learn this formula thinking that final formula after dipole approximation you have to do. No. Class, 2 kpr by r square minus a square to the power whole square, this will be used in the exam. Questions have come from this, where r and a are comparable. Both are having approximately same value, so you have to use this. So do not neglect this formula. Same goes for equatorial also. Equatorial is rather easy. Many a times the question on equatorial has come a lot as compared to axial, because in your equatorial your vectors usage is more. That's why. Otherwise anything can come in your paper. So same thing, same goes for it also. Ideal dipole approximation, when this is the condition, do not use it otherwise if you have both the values. If you just have a single value, no, r or a, single value, and you're not able to identify whether it is a given or r given, because some question is there also in your previous year. So that time use directly this when one value is given. When both the values are given, use this. If it is comparable, then directly use this. If you see a difference, one is centimeter, other in meters, or one in millimeter, other is given in meters, that is the difference, then use this. So this is what you require in axial and equatorial. Now regarding the direction also, dipole moments, that's why I'm saying dipole moments direction is very important. And the problem with dipole moments direction is that at the end of the syllabus, now you have magnetics also. In magnetics also, you have so many directions. This hand rule, that hand rule, hand is like this, palm rule, finger rule, all these. So it becomes difficult to remember the direction. So the dipole becomes confusing, and what it is too difficult to remember. So keep this in mind. And this part, E axial is equal to 2 times of E equatorial. This also class, this can also be asked to you. So that time it will be asked to you in your lesser marker questions on your 1 or 2 markers. So that time you have to show this part. Apart from this, directly numericals will be asked to you. These questions which we had discussed in the class. This whole entire OneNote, I have shared it with you already on WhatsApp. So those who want, you can open up the link and see. Now electric field lines properties are asked. From this part, no theoretical, no tough question, no question will be there that will be based on formula. Direct these properties, these class. From this point, tangent point, then they're closely spacing till this 6th point, till this final point that you have. 8th point. This can be easily asked to you in the exam, and it will be a very good question to score. If the paper has to be easy, in your easy examinations, this question will be given, electric field line. In your NCRT also, you have the questions where the directions are given and you have to identify whether it's correct or incorrect. So that type will not come. I to identify whether correct or incorrect. But directly writing about electric fields will definitely, it can come. There are chances. So you have to mention that electric field lines are tangential to the point. Then you have to show that wherever electric field lines are closer, that depicts that a stronger electric field exists, while when they are at a certain distance, that denotes weaker electric field. Then origin to the insertion, that is the termination, that is the field lines are originating from positive charge, terminating into negative charge, and class. This individual depiction for positive charge, for this negative charge, and this dipole, this has been asked in your exam. So this specifically, this point number 3, this can be separately also asked to you. Fine. Then you have continuous curves are present. Yes, these are not very important. Longitudinal contraction and these points are not very important. But whenever you're writing your complete answer, do mention it. But otherwise, separately it won't be asked. Neutral point is important. Neutral point is important. Why? Because you have questions from electric field and forces, electric forces based on neutral point. Calculate at the neutral point. Find the neutral point. So neutral point has that significance only. Otherwise, neutral point has no other significance. And this also, you just have to mention it. Electric field lines are perpendicular on the surface of conductor, because this point relates with your potential and capacitance. Fine. So this is what you have to remember for electric field lines. From this topic, electric field lines, whenever you're studying, the way we study, how do you study? First, do the important part first. And then whenever time is left, then do the necessary parts which you think are not very much important. So electric field lines mein properties, you have to go through it once. Next, torque. Torque, questions on torque are usually asked in the exam more than the derivation, because torque parts, derivation and everything is actually a part of class 11. But if it comes to write down about torque, see, when you write about torque, you have to show this is first the charge and then external field. See, this is direct from your kinematics, motion in 1D. Nothing new in this. Same thing, same equations of motions you have to apply. Fine, same equations of motion. And yes, class, this is a technique whenever you find the question is from electrostatics and you're not able to solve the question further, you're not able to identify how to solve the question, whichever variable is there. Class, electric forces formula, electric force, Q into E, or complete formula Q, K, Q1, Q2 by R square. Whatever other force will be given, usually it is equal to that, because maximum times in your marking scheme, in your solution, it is written that since net force is not acting, isolated system is there, so this force is equal to electric force. If you think it's a circular part where a centripetal force can act, equate electric field to centripetal force. You think gravitational force can act, equate it with whatever force you think that is present, tensions, equate it with wherever you see. Even if you're not able to relate whether it's equal or not, this is just a technique. Many a times it is equal, like in this question. Many times if net force is not acting, usually forces are equal. These questions also, do prepare it from. Firstly, class questions that we have discussed in the class notes, do that first. Because I have seen yours papers and maximum papers that have come in this year, your half yearlies and mock exams that have occurred. In that, many questions were directly from the class notes only. And in your paper also, Salman and Khalid's school, that paper also which you shared with me, those had simple questions. So for your pre-boards also, pre-boards are, do you have your schedule now, class? Or still the schedule?
We have got our schedule.
You have got your schedule. Share with me on WhatsApp, Salman, then?
Yeah, okay.
Okay. So this question can be asked to you. So same thing, kinematics you have to apply in such type of questions. Same thing, kinematics you have to apply along y-axis, x-axis. Now, main thing in torque is, see, if you are asked to derive torque, so nobody is going to start directly from here. No, you will have to mention this part, that QE is cancelling minus QE, means net force on dipole is 0. This you have to mention whenever you are writing about electric field in non-uniform. Okay, Salman has shared, no? Circular. Physics is on 10 Jan. Okay, so you are getting a good time, Salman and Khalid, both of you. So your exams are actually starting from 3rd.
No, that
Physics is
is
on
physics.
15. Okay, that is 11. So physics is 15. Okay, then. And main exams are from 3rd. So you both have maths and bio?
No, we take math and computers.
Maths and computers. Okay, both of you. So this bio part will also be empty for you. So directly physics will be your last paper on 15. And now your date sheets are not released, no class? Date sheet for your board examination is not released, no?
From CBSE, no, I don't think
No?
so.
No, it has not been released. Okay, let's wait for that. But your date sheet is fine. I think you will get sufficient time to write it down. Now, class. Electric dipole in uniform electric field. This yes, I was saying whenever it comes for to write about torque, do mention this point. Nobody is going to directly start from here. Do mention this, that net translational force is 0. Then for torque, you have to write P cross E, and PE sine theta direct easy questions come from it. Not very difficult questions. Torque, you will be able to manage it. Electric flux. I would suggest whenever, since you all have prepared and you all are aware of this lesson, to directly start from Gauss theorem, because this is the most important topic. So if possible, start from here. Otherwise, go into your sequence, whatever you're finding it convenient. Because this part, phi is equal to ES cos theta, this part, and this, basically the Gauss theorem statement that you have, that is very important, very, very important, and that is directly asked to you. The Gauss theorem, Gauss law will be asked. Now see, electric flux's formula, direction of area vector. Class, again I'm repeating this, when we were discussing the questions that time also I had discussed with you, that you tend to take up the area vector as the plane. Area vector will be perpendicular to the plane surface. All right, area vector will be perpendicular to the plane surface at all the points. Then curved surfaces are there for hemispheres. This, this we had discussed. Electric field basic formula will be there. Now Gauss law, this point, Gauss law, whenever it is asked, if it is asked in 1 marker only, then write the statement. If it is asked for more than 1 mark, 2 marks or 3 marks, then you have to mention the properties along. Then only you will get a good score. Otherwise, you will get just half or 1 mark only for writing the law. Law has 1 mark, but properties will make your good combined answer. So Gauss law is, according to Gauss law, you know that 1 by epsilon naught times the total charge enclosed. Remember, it's the total charge. Do not consider one charge or second charge. Fine. Properties, independent of shape and size, and you have to only consider the enclosed charge. And electric flux, outward flux will be positive because it's for positive charge. Negative flux, inward flux will be negative because negative charge, we usually move towards it. If theta is 90, it will directly be 0, or you can say field lines are actually not crossing it. They're just passing it by it. For dipole, flux will always be 0. This, yes class, this part, 5th part, this is also asked a lot. Dipole, flux for dipole, and this will be related to your equipotential surface that we'll see after we do complete the first chapter. And then continuous charge distribution, this you know, lambda is Q by L, means three types of charge distributions. You have linear charge distribution, surface charge distribution, and volume charge distribution. So in linear charge density, you have charge per unit length represented by lambda, charge per unit length. When you come to superficial charge distribution, that is the surface charge distribution. It is also known as surface charge distribution. That is charge per unit area. So one dimension increases in the denominator. Charge per unit area, charge per unit length, charge per unit area. Then you have volumic charge distribution. So in volumic charge distribution, you have charge per unit volume. One more dimension gets added in the denominator. Charge per unit volume. Charge per unit length, charge per unit volume. So charge per unit length, charge per unit area, charge per unit volume. Questions from this will be direct, but most of the time this is used in other questions in other topics. So if question comes directly from this, it will be easy, direct formula based. But many times you have to use this concept if it's a difficult question to solve it. Now let's see the question part from this. Some numericals let us practice, some types of questions which we have not practiced. Then we'll move on to the second chapter. And any doubts in electrostats you have, you'll let me know. Class, electrostats we are ending today. Current electricity we'll do on Wednesday. So prepare current electricity, revise current electricity and come. And any doubts you have, 1 week time also you got. Any doubts if you have marked, any portion that was weak, that also let me know from current electricity. Okay, let us practice some questions first. See class, here you have the force as a charge Q is said to be divided on two objects. What should be the values of the charges on the two objects? So that force between the objects can be maximum. So force is 1 by 4 epsilon naught. If one charge is Q, let's say other charge is small q. So small q will be, see Q, one charge is Q and this charge is to be divided between two objects. So one will be Q, another will be Q minus small q, right? One part will be Q, another part will be Q minus Q. Then only you will add it and you will get Q back. So here you will do Q minus small q, and then you have the separation. Take it as R square because that is not very much needed. Now see, for maximum force, you will equate dF over dQ 0. Why? Because force is to be maximum. So when you differentiate it with respect to the charge, that is, this is when force is to be maximum. So dF over dQ is 0. All right. So this is for the maximum force because you're differentiating it. Now see, equate the entire term 1 by 4 pi epsilon naught 1 by R square. You are integrating this whole term. Q, or just multiply Q by within the bracket only. Small q into capital Q minus Q square is equal to 0. So you will directly be left with Q, small q, minus Q square. This rest of the term will be 0. You are just differentiating this equal to 0. Now C class, when you're differentiating this term, small q and capital Q. From here, small q is variable, capital Q is constant. So capital Q will come out minus Q to the power 2. That will be 2Q equal to 0. So this small q will be equal to capital Q by 2. Okay, note it down. Some more numericals we'll see. See, this says that a charged spherical conductor has a surface charge density of 0.7 coulomb per meter square. When its charge is increased by 0.44, see, surface charge density, sigma is Q by 4 pi r square. Surface charge density, charge per unit area for sphere, 4 pi r square. So Q by 4 pi r square. So first case says that 0.7 is the surface charge density. So it will be Q by 4 pi r square. Second part says when the surface charge density is increased by 0.44, it means 0.7 plus 0.44. Charged is increased by, when the charge increases by 0.44. No, I have written opposite. Surface charge density increases by 0.14. Here it is given, 0.14. So charge increases by 0.44 by 4 pi r. Now you just have to find out the value of r and q. This is what is the question. So two equations you have. You can simplify both these equations. See, using these two equations you have to write. So if you divide both of it, so see, this will be 0.8, 0.84 q 0.44 by 4 pi r square. Now take their ratios. So see, when you take the ratio 0.84 by this term, 0.7, 4 pi r square will get cancelled. So q plus 0.44 by q will be left. Now you have to solve this. So it will be 6 by 5. No, this part will be 6 by 5. Q by Q, 1 plus 0.44 by Q. So Q will be 2.2 coulombs. Once you have the value of Q, put it in the value of, you will get the value of R as under root Q by sigma into 4 pi. So properly substituted Q, you have now 2.2. Sigma was given as 0.7 and then you have 4 into 3.14. 22 by 7, I think if we take that will be better. See, 22 by 7, if you take 1 by 2 will be left. So 0.5 meters. So R will be 0.5 meters. Note it down, class. See class, it says that S1 and S2 are two concentric spheres, R1, R2 radii given, Q and 2Q are the charges, and S1 and S2 are the two spheres that we have. What is the ratio of the electric flux through S1 and S2? So electric flux is is easy. See, if you apply Gauss theorem, flux through S1 will be, which is 5, and it will simply be Q by epsilon naught, because total charge enclosed by the first sphere is Q. If you talk about S2 surface, that is surface 2, spherical 2, so total charge will be what? See, Q charge is there from the first sphere. This is S2. So what is the total charge enclosed in S2? Yes, what is the total charge enclosed in the sphere S2? Khalid, Salman, Memuna. Total charge. Yes, Khalid, you were trying? If you will not answer like this, I'll have to take your separate vivas.
Teacher, S2 will be like 3Q.
3Q, yes, 2Q plus Q. And as soon as the question is asked, Salman runs away. So according to his way, he has ran away again. So 2Q plus Q, that makes it 3Q. Salman, why do you get scared as soon as a question is put up?
No. I left by mistake. Like the internet.
Every time.
No, ma'am.
Okay, so flux through S2 is 3Q. Now take the ratios, phi1 by phi2. So Q by epsilon naught, then 3Q by epsilon naught. Ratio will be 1 by 3, 1:3. Second part says, if a medium of K, dielectric constant K is introduced, then what will be the difference in the flux in S1? That is second part, and S2, that is the third part. C class. And please, this is the most important question of all the questions we have discussed. If a medium of dielectric constant K is introduced in the space inside S1, flux through the space S1, it is E dot ds, closed loop integral of E dot ds. So this becomes, electric field will become E by K. This was the earlier electric field, electric field dash, let's say. So E dash will be E by K. And then integral of ds, closed integral of it. So see, 1 by K will be taken common, and you are left with E dot S, closed integral. E dot S is simple Gauss theorem, which says Q by epsilon naught. Make this as also phi dash. So final answer for phi dash will be Q by epsilon naught K. Now see, if it is introduced through S1, it does not change. Flux through S1 does not change with the introduction of dielectric medium inside the sphere S2. See, S1 it can be, S2 it does not change. See here, this is the first sphere, S1. Here you were introduced K, you got it. Now when you're talking about 2, flux through S1 does not change. When you are introducing medium in S2, means whatever answer will still be the same. Answer will come out still be this only. So question is asking you the change. So there won't be any change. Same answer you will get. No change. Note it down, then we'll start with the rest part of electrostatics that is left. Potential we have to discuss. Note down the question and the solution. So from your chapter 2, so electrostatics, let us just complete electric potential. So whatever you have studied from electric field, no, those similar questions can come from electric potential. Again, this also I think I've shared on the group only OneDrive link that you can open and see whatever portion I've been used. Otherwise, you people were constantly present throughout, I think. Hardly Khalid and Salman, for both of you, I remember you have taken leave. Maimuna was also regular initially only. I think from August she had started taking leave. But before that, when these lessons were going on, you three were regular. So electric potential will be work done in carrying charges from one point to another. When you have potential energy, that is when you take the charge from infinity to a point. When you talk about potential, you take charge from one point to another point. That is the difference between potential and charge. Potential is simplified version because in potential, you do not have the headache of the vector quantities, simply adding it. Negative to negative, positive to positive, like that. Formula this in your examination class, if definition comes, this part along with till this point, this formula, this also you have to mention, otherwise your marks will be deducted. This you have to mention along with this definition. Definition, scalar vector, SI unit. These three have to be written everywhere. Formula and the properties depending on the marks you have to write. Because these questions are usually not of very good score, 2 to 3 marks only. All right, so this is potential for a point charge. Formula will be same thing, just eliminate one charge from it. So KQ by R. Force was KQ square by R square. Electric field was KQ by R square, and eliminate the radius, that becomes KQ by R is potential. The rest of the thing will remain the same. So this is superposition principle of it. Superposition principle will be same, but the difference in superposition principle of the potential will be that these are added algebraically, whereas electric field and electric force were added vectorically. This is the difference that arises. Fine. This question comes a lot. Work done is equal to charge multiplied by change in potential. Means many questions are there where this formula usage is done. Charge multiplied by the potential. This is asked in the exam. These types of questions, these will be asked to you from electric field also, from force also, from potential, especially from potential. This question, specifically this question has been repeated. So as I've told you, whenever you are revising, first go through your notes. So once you go through your notes, many portion of previous year and rest of the syllabus will be covered. So from this topic, you just have these points. You have to remember nothing is new. The way you had studied for electric field, that you have to remember. Potential of dipole. Yes, class. From here, you have certain good topics that are new to this lesson. See, dipole, one general derivation you will do. Axial is asked or equatorial is asked. Show the general one and put in the angle. Like this is the formula for the general formula. So axial and equatorial, put the angle. And class, axial and equatorial line, this general formula derivation for potential is also asked in the exam. These derivations, axial, equatorial for electric field and potential, both are asked in your exam. So this will be mentioned. This is the basic question. Yes. Class, this is very important. E is equal to minus dV over dr. This is very, very important class from potential. A lot of chances are there that question will come from there. Partial differentiations do not have so much chances, but the normal simple differentiation or simple V divided by R minus V by R, this will be asked to you in the exam. And this significance of this negative sign direction of electric field is where potential decreases, and electric field is gradient, potential changing with respect to distance. These 2 points that are given in the book also, these are very important. Questions have been asked and questions are asked. This is very important from this lesson. Rest of the things which were similar that I told you, that these are not. Partial derivative is also not very important. Questions are there, but mainly questions are from E is equal to minus dV over dr and derivation of the potential. Then class, something new and unique for this lesson is equipotential surface. And in equipotential surface, you get again your conceptual questions. So in equipotential surfaces where all the potential at every point will remain the same. So whenever questions are on equipotential surface, if it's a numerical, then mostly it's work done. Work done is zero or change in potential is zero, like this. But if it's a theory question, then that time you have to mention definition of this with this example along with the entire property. First property, you will mention that potential will remain the same. Then you will mention that since potential remains the same, work done will be zero. Then you will tell electric field will be perpendicular to equipotential surfaces, and wherever equipotential surfaces are closer, that depicts strong electric field. Wherever they have a certain distance between them, they are kept far apart from each other, that will represent weaker electric field. This will complete your one question. For 2 marks, even if it is asked, properties mention it. One line properties just mentioned. Draw for isolated charge are also asked. These have been asked, but if it is asked, direct questions are there. But mainly more important topic is this, because from these properties points, like work done and all these points, questions have been asked separately. Then electric potential energy, as I've told, when it is from infinity to a point, same thing as potential, but one point becomes infinity, another point becomes that particular point. Understood? Electric potential energy is what? Electric potential energy is the work done by external force in carrying charges from infinity to whatever is their respective position. So potential energy of a system of two charges is given. See class, just remember it this manner only. Infinity to a point, energy. One point to another point, potential. Rest of the calculations remain the same. Why is there a difference? Because when you integrate it, when you write it, it's from infinity to 1 point, otherwise one for energy, it is R1 to R2. This is just the difference. So from here, yes class, for point charges, for first one, you will make it as 0 because no other charge was present to interact with it, to exert potential energy on it. Plus potential energy questions, when it comes from potential energy part, to remember that you have to mention about the interactions. You will see which two charges are interacting with each other. If you see one interaction is completed, mark that as 1. Whether it's located diagonally, whether it's located horizontally, parallelly, whichever manner, just make it as 1. Interaction means both the charges can exert force on each other. So potential energy questions are based on this. The way in class 11th you had gravitation, same thing, exact copy of the gravitation part. All right. So this way only, like two charges you see and then store it in the form of potential energy. This had two charges only, but questions like this, many times we just see that 4 energies can be obtained, but no, these diagonal energies are also at an approachable distance, so they will also interact with each other, and these two diagonals also, BD and AC, both can interact with each other. That will result in 6 energies. Likewise, you will be having different systems where you will see which two charges are approachable to each other, which two charges can interact with each other. Fine. So in potential energy, this is the main thing that you have to remember. Then when it comes to potential energy for dipole class, this derivation is important. Mark this derivation as important. This one. Potential electric energy of dipole. This derivation comes. Formula questions are easy on this. Direct questions can come. And in this, the questions can become tricky from this part. Yes, this part I was searching for. When it is 0, it will ask you when it is stable, when the potential energy is unstable, when it is maximum, when it is minimum, when it is in stable equilibrium, all these topics, these are mentioned. So when it is 0 degree, it will be in stable equilibrium. When it is 180 degree, it will be unstable equilibrium. Like this. Then direct questions. See, questions are direct on this. Questions will be direct from this. Work done by electric will be negative of work done by external. Just keep that in mind. Otherwise, this part, theory part will come from this. Theoretical questions will be from here. Then that completes with electrostatics. You have just capacitance left. Let us discuss that so that we can move on to the numericals. C class, ability to store the charge, that is known as the capacitance, and the device that does this function to store the charges, it is known as capacitor. Now ratio of the charges. This is the basic formula. Q is equal to C is equal to Q by V. From here you will use Q is equal to CV. You will write V is Q by C. Every formula will be derived from this one. This is a very basic formula. Now 1 coulomb by volt. This is the SI unit of it. But 1 coulomb by 1 volt, we do not use it. We write farad. So 3 microfarad, 4 millifarad, likewise we use it. So capacitor basically stored charges. When your mobile phone, no, the flashlight store charges, and once you are using it, it releases all the charges, and then it again stores when you charge the mobile phone. This part for conducting sphere, this part, 4 pi epsilon naught r. This is important. This is similar. C prime is equal to K is C, not so very different and unique, but this part, class, this is asked. This, if you look up the previous year papers, this part you will notice for conducting sphere. Write down the formula or derive the expression for capacitance of conducting sphere. Small mark, 2 marks or 3 marks will be given, but that will have a good weightage for it. Then yes, 711 microfarad. When you mention about the conducting sphere, if it is for a 2 marker, then write it till this step only. Fine, this is enough. C prime will be 4 pi K epsilon naught r. If it's for a 3 marker, write this along with this. That value of capacitance of earth is 711 microfarad. Mention this as well. The capacitance is 711 microfarad. That way only you will get marks. Like when I check your papers, especially you, Salman, you write very less in the answers. You know the answer, but you omit most of the things while writing, and maximum question calculations you do orally only. That will not give you score in your board examination. Board examination asks and requires a lot of answers. Okay, I hope you're understanding this. Then capacitors, mainly most important are parallel plate capacitors for you. All the 4 cases for parallel plate capacitors, these derivations I'm not discussing. I'll directly come to the conclusion. I had written it somewhere. Yes, this part. All the 4 along with the formula, along with their derivations are important. Parallel plate capacitor. If you get time left, then have a look at the spherical capacitors and the cylindrical capacitors. But if time is not left, if time does not permit, do not look even at it. Just focus on the 4 conditions and the derivations of these. Derivations will also be covered and formulas will also be done. And questions will be from this part only. Completely filled air, then it is epsilon naught A by D. If dielectric slab is introduced, then it becomes K times C air, that is K epsilon naught A by D. If a thick slab is introduced with a certain thickness, partially thick, you write epsilon naught A by D minus T plus T by K. And for partially filled conductors, we write epsilon naught A by D minus T. Energy stored in capacitor is also important. And this is easy to learn and remember, and questions will be from this part as well. Questions are there from this derivation can come. Q square by 2C. Q square by 2C can come, like half Li square can come from your inductor part. No, this can. Spherical capacitors are not very important, as I'm saying, whenever time is left. Class, these questions are important from this. Whenever in the class also I had mentioned to you, force between the parallel plates capacitors and energy density. These. Why are these important? Because directly derivation, direct exact questions can come like this, derivation part, or straight away numerical will come. So if you do not remember this separately, otherwise the rest of the questions we do it generally. These 2 questions specifically involve the derivation part. These are exactly like derivation done in the form of question. Energy density, force. Fine class. So direct questions can also be asked to you from this. Then sharing of capacitors. In sharing of capacitors, this is like charge only. How from a higher potential charge moves into lower potential until potential remains the same. Its derivation looks haphazard, but when you solve it, when you see it properly, you will see that it is not difficult. You write everything that all the things before sharing, everything after sharing, and then you will notice that when you equate it, you will get, yes, common potential questions are asked and loss of energy is also asked. This derivation is not very much important, but the formulas are used. Questions are there on formula. So this formula, the final formula for loss in energy, that can also be asked. Final formula for loss of energy, that can be asked to you. And then combination of series and parallel, obviously this we have covered, and this is exactly opposite to resistors. Once you need thorough practice for this parallel and series. So for series and capacitance we reciprocally add, and for parallel combination we directly add. For series we reciprocally add it. Reciprocally addition means 1 by C1 plus 1 by C2 plus 1 by C3, whatever it, that is for series. And for parallel is simply C1 plus C2 plus C3 plus C4. Straight away you add like this. Let's practice some questions now. Questions from this topic. And any doubts if you have specific topics are left. If you want any topic to be discussed, then you can let me know. First, let us practice some questions. See class, this question says calculate the voltage needed to balance an oil drop carrying 10 electron when located between the plates of capacitors which are 5 millimeters apart. So number of electrons is 10. In questions, no, write all the data that are given usually. So that makes the questions easier. So 10 electrons are there. So what will be the charge on every electron? Q is equal to NE. So 10 into 1.6 into 10 to the power minus 19. That will be 1.6 into 10 to the power minus 18. Then it says these are separated separation distance between the plates is 5 millimeters. That is 5 into 10 to the power minus 3 meters. And mass is 3 into 10 to the power minus 16 kgs. Now, class, we have to find out voltage. Potential is missing now. So see, electric field will be potential divided by distance. Electric field will be potential divided by distance. So E will be V by D. That is V by 5 into 10 to the power minus 3. And you know, QE will be equal to mg. As I've told you, these forces usually balance each other. So whenever you see no external force acting on your system, equate it. Now put the value of E. Charge is 10 to the power minus 18. 1.6 into 10 to the power minus 18. Put the value of E from here. V by 5 into 10 to the power minus 3. Mass is given as how much? 3 into 10 to the power minus 16, and acceleration due to gravity 10. So from here, you can get the value of potential. 3 into 10 to the power minus 6 into 10 into 5 into 10 to the power minus 3 by 1.6 into 10 to the power minus 18. Solve it, see whatever answer you are getting. Note it down. Yes, Memona, it is 9.47 precisely. Correct. Almost you're right.
Ma'am, I'll round it off and then calculate it. It's fine, right?
What are you getting? Which answer, Salman?
Close to 9.5.
9.5. No, yes. So 9.47 will approximately exactly will get. So approximately 9.3, 9.5, which you people are getting. That is fine. Because we have taken G as 10 meter per second square also. No, that's why. Try this question. Send me the answer which we're getting. See the solution for this. Two electrons are there. Both are having their velocities as 10 to the power 6 meter per second, and they are moving towards each other. Distance, how will you calculate? If two electrons are moving, they are having their velocities that is mentioned, and they are moving towards each other. So there will be certain separation. You can notice the total kinetic energy of the system will be equal to potential energy. So what will be total kinetic energy? Will kinetic energy of this electron, kinetic energy of this electron, plus potential energy in between them. So that will be half mv square plus half mv square from the second electron. Then k E1, E2 or E into E by, let's say this is some R square. 2.5, yes, Salman, correct answer. So that makes it mv square only. Mv square is ke square by R square. So R will be equal to R square. No, not R square. Potential energy will not be R square. Potential energy will be only R. So R will be equal to ke square by mv square. So k will be 9 into 10 to the power 9, electronic charge 1.6 into 10 to the power minus 19 whole square. Mass, okay, electron is given, no? So mass will be 9.1 into 10 to the power minus 31. Velocity square 10 to the power 6 whole square. So when you solve it, you will get the answer which he is getting, Salman. 2.53 into 10 to the power minus 10 meters. Around this much. Note it down. I'll share one more numerical. Answers. C2 capacitors have a capacitance of 5 microfarad when connected in parallel. So in parallel, we'll write C1 plus C2 as 5 microfarad. And when in series, 1.2. So 1 by C1 plus 1 by C2 will be 1 by 1.2. Or you can write this as C1, C2 by C1 plus C2 as 1.2 microfarad. So put in the values of C1 plus C2 from here. So C1 into C2 by 5 will be 1.2 microfarad, which is 6. 5 into 1.2 will be 6. Or you can do one thing. Write the value of C2 also. C2 will be 5 minus C1. Put it here. So C1 into 5 minus C1 will be 6. Now using this equation only we can get our final answer. So this will be C1 square minus 5C1 plus 6 equal to 0. Because every term we have brought it on the next
Minus 6,
slide.
right?
No, we have brought
Brought
these
it to the other
terms.
side, okay.
Yes. So this will, otherwise that would have been minus C1 squared, no?
Yeah.
So this will be what? 6, 3 and 2. 3 into 2 is 6. And 3 plus 2 is 5. So 6 and 2 we'll get, no? C1 will be 3 into 2 will be 6. Right, 2 and 3 only, no? We'll get 2 microfarad and the other one will be 3 microfarad. Note down, class. Do we have time? Yes, one last numerical we'll do. And please, class, be prepared for current electricity. equivalent capacitance we have to calculate. See class, in this question, no, here 60 microfarad, 60 microfarad and 60 microfarad, these three 60 microfarad, these are all connected in parallel. They are all connected in series. You can see the wires have just turned. The wire is just turned. Curvature of the wire is there. Straight wire is there. No branching is there. You can turn the wire. Remember, we had discussed all these things. So all these three are connected in series. So if they are connected in series, so 1 by C1, let's say it will be 1 by 60 plus 1 by 60 plus 1 by 60. Or in better manner, we can simply divide 60 by 3. So you will get 20 microfarad. If this entire apparatus is 20 microfarad, now see how your system will reduce. 40 microfarad will remain. There was 10 microfarad. Sorry. With which a parallel 10 microfarad was connected. Now the portion above it, that has been reduced to 20 microfarad. So now you can see these three. How are these three connected? Series. Parallel, no? Good. They are connected in parallel. So C2 will be simple addition of it. 10 plus 10 plus 20. That will give you 40 microfarad. Now how will we reduce our circuit? Our circuit will get reduced further. So this will be, here you have this 40 microfarad. And now also you have this 40 microfarad. So A point and B point. Now you can see these two, these are directly connected in series. So your answer C equivalent, 1 by C equivalent you can write. This will be 1 by 40 plus 1 by 40. Or you can write C equivalent directly, 40 divided by 2, that is 20 microfarad. So look how a huge circuit. This was the circuit given to you. So simply step by step, keep on reducing. Note it down, be prepared for current, electricity and come. It will ease the work. And class on Friday also, we have to take one more revision class. Then only, in 2 weeks span, you will be completed with the syllabus. And you'll get sufficient time to prepare for your boards. Otherwise, syllabus will keep on, your whole entire revision will keep extending till the month of Jan. So it's better, let us complete it till 23rd December. 1 class today, 1 class, so 14th current, electricity. I'm just saying in advance, please have your Fridays free.